Welcome to Infra Explained, the series where we unpack the tools that quietly run modern software. In this first episode, we're tackling a big one, Docker. At its heart, the idea is wonderfully simple. Package your app, along with everything it needs to run, into a neat little box that behaves exactly the same way, no matter where you ship it. But before we get to the box, let's talk about why we need one in the first place. Every developer knows this story. Your app runs perfectly on your laptop, you push it to the server, and it immediately falls over. Different operating system, a missing library, the wrong version of something. Hours disappear trying to make two environments match. So the question becomes, what if you could ship the app together with its entire environment so it behaves identically everywhere? That bundle, that's a container. So here's the whole idea in a single sentence. Docker packages your application together with all its dependencies into a lightweight container that runs the same on any machine. Three things to hold on to. 1, it bundles your app with everything it needs to run. 2, it behaves identically wherever you launch it. And 3, it's lightweight. We're talking seconds to start, not minutes. That's the promise. Now, let's look at how it actually pulls that off. Before we dig into the mechanics, here's the analogy that makes it all click. Before shipping containers, cargo was loaded loose, slow, chaotic, and every ship, truck, and crane handled it differently. Then came the standard steel box. Pack it once, and any port in the world moves it the same way. Docker is that box for software. Your app and its dependencies go in the container, and the Docker engine is the crane that lifts it onto any machine. Now, if you've worked with virtual machines, you might be thinking this sounds familiar. And you're right, both isolate apps, but the difference is in the weight. A VM bundles an entire guest operating system on top of a hypervisor. So running 3 apps means booting 3 full OSs. Containers skip all that. They share the host's kernel through the Docker engine, so each one carries just the app and its dependencies. No guest OS, no hypervisor, just a much lighter box on the same hardware. Before we go any deeper, let's lock in 3 words you'll hear constantly. First, the Dockerfile. That's just a text file, a recipe with instructions for building your app's environment. Run that recipe through a build, and you get an image, a frozen, ready-to-ship template. And when you actually run that image, you get a container, a live running instance. So the flow is simple. Dockerfile, build, image, run, container. So let's actually look at one of these recipes. We start with from. That picks our base image, in this case, a lightweight Node 20 on Alpine Linux. Workdir sets the folder we're working in, then we copy the package, jjasn, and run npm install to pull in dependencies. After that, we copy the rest of the code, expose port 3000 so the outside world knows where to knock, and cmd tells the container what to launch when it starts. Top to bottom, that's the whole build. Readable, repeatable, and version controlled, like any other file in your repo. With the Docker file in hand, the day-to-day rhythm comes down to just 4 commands. You Docker build to turn that recipe into an image, then Docker run to spin up a container from it. When you're ready to share, Docker push uploads the image to a registry, and anyone on your team or your production servers can Docker pull and run the exact same bytes you did. Build once, ship the image, run it anywhere. That's the whole promise. Now here's where Docker gets clever about efficiency. Every instruction in your Docker file, the from, the copy, the run, creates its own layer, stacked on top of the last. And because Docker caches each one, when you rebuild, it only redos the layers that actually changed. So if your package.json hasn't moved, npm install doesn't run again. Layers are also shared between images, which keeps your disk usage surprisingly lean. So with all that efficiency under the hood, it's worth stepping back and asking why teams actually reach for Docker in the first place. It comes down to 4 things. Consistency, because the same image runs identically in dev, test, and production. No more works on my machine. Speed, since containers share the host kernel and start in seconds. Isolation, giving each app its own clean space. And portability, meaning that image runs anywhere from your laptop to the cloud. But Docker on its own is really just the starting point. Around it sits a whole ecosystem that makes containers genuinely useful day to day. There's Docker Hub, which is basically GitHub for images, where you pull and share pre-built containers. Volumes let your data outlive the container itself, so nothing important vanishes when it stops. Networks give containers a way to actually talk to each other, and Docker Compose ties it all together, letting you spin up a whole multi-container app from a single file. And Compose is honestly where things start to feel magical. In this little YAML file, you're describing a whole system, a web service built from your current directory, exposing port 3000, and a Postgres database it depends on, with a volume so the data sticks around. Then one command, Docker Compose Up, brings the entire stack to life. No more 12-step setup guides in the README. Now, before we go further, let's clear up a few myths that trip people up early on. A container isn't a lightweight VM. It shares the host's kernel rather than booting its own operating system, which is exactly why it starts in milliseconds. It's also not secure by default. Isolation buys you separation, not a security boundary. So your images and configs still need hardening. And Docker won't keep your data safe on its own. Containers are disposable, so anything outside of volume disappears the moment the container dies. Which leads us straight into the security essentials worth burning into muscle memory. On the DO side, stick to small official base images, run your processes as a non-root user, scan regularly for known CVIs, and pin your versions, because latest has a funny way of changing the night before a demo. On the avoid side, don't run as root. Don't bake secrets into image layers. Don't bloat your images with tools you'd only need to debug. And please don't blindly trust random images from the public registry. With the principles in place, let's take a quick tour of the toolbox you'll actually reach for. Day to day, it's Docker build and run for the core workflow, Compose when you've got multiple containers talking to each other, and Docker Hub as your default registry. Beyond that, Trivia and Scout handle vulnerability scanning. Docker Desktop gives you a friendly GUI for local work, and Kubernetes waits in the wings for when you need to orchestrate containers at real scale. So let's pull the key ideas together before we move on. Docker packages your app with its dependencies into a container that shares the host kernel. Lighter and faster than spinning up a full VM. The flow to remember is Dockerfile, build, image, run, container. And those images are layered, cached, and shared through registries. And one last thing worth burning into memory, containers are disposable by design. So anything you actually want to keep lives in a volume. Now that you know how it all works, the real question is when to actually reach for it. Docker shines when you need consistency between dev and prod, when you're running microservices or APIs, when you're wiring up CI/CD pipelines, or when you want onboarding to be a single command instead of a half-day setup, but it's not always the right tool. For a tiny static site, a throwaway script, or when a managed platform already handles things for you, Docker can be more ceremony than it's worth. Pick the right tool for the job. If this sparked your curiosity, there's a whole Infra Explained series waiting, covering Kubernetes, CI/CD, containers versus VMs, and infrastructure as code, all in the same plain language style. And one quick word of caution, containers aren't secure by default. As you start moving toward Kubernetes in production, hardening becomes essential. So the SSH Hardening Mastery course over at Dargslan.com courses is a solid next step. Before we wrap up, I'd love to hear from you. Do you Dockerize everything in sight, or do you keep it selective and only containerize the things that really benefit from it? And be honest, what was your first "it works on my machine" moment? Drop it in the comments. Those stories are half the reason we all ended up learning this stuff in the first place. And that's Docker. Hopefully a little less mysterious than it was 20 minutes ago. If something finally clicked today, hit subscribe because Kubernetes is up next in Infra Explained. And trust me, it makes a lot more sense once Docker feels natural. Thanks for watching, and I'll see you in the next one.